In this video, we are looking at matrix applications with the help of scientific calculators. Let's say we are given a data matrix D, right, and a column vectors Y bar. Our task here is to compute W bar, right, given by this expression, right, which is also known to be the closed form solution for linear regression model. So how do we compute this W bar? Using a scientific calculators, assuming that the lambda that we are using here is 205. The key challenge with the scientific calculators is that it can handle, right, only maximums of 3 matrices, right, with a max size of either 3 by 3 or 4 by 4 each. To address this particular challenge, right, we can utilize a trick from linear algebra, which is known as the outer products views of matrix multiplications. Let's say we want to compute the products between these two matrices. We will be able to rewrite it as the outer products between columns from the first matrix with rows from the second matrix. And with the same idea, we will be able to rewrite, let's say, right, the first 3 outer products back to matrix products form, right? Similarly, right, for the next 2 outer products, we will be able to rewrite it back into matrix multiplications form. Right, we will highlight the difference between the original expressions with the new expressions with color box. And with that, right, you will be able to see the key differences between the original expression, right, with the new expression. Right, the original expressions cannot be keyed in to the scientific calculators directly, but the new expression, right, will allows us to key in, right, all the values, right. We will be able to compute the expression, right, with the help of scientific calculators, right, because the size of the new expression, right, does not go beyond, right, a matrix of size 3 by 3, right, or 4 by 4. Next, we will proceed to compute W bar. We will start by computing D transpose Y bar, right, because this will help us reduce this particular expression into a column vectors, right, M bar. And we are not able to throw in this D transpose Y bar, right, into a scientific calculators directly, right, because the matrix D transpose, right, is having a size of 3 by 5, right. There's no way to key in D transpose directly into our scientific calculators, right. Similarly for Y bar, right, so we will have to apply the outer products views of matrix multiplication that we just discussed, right. So we have to break down, right, the matrix products, right, into the sums of products, right, between smaller matrices, right, that provide us, right, a way to compute D transpose Y bar, right. So what we are showing here, right, is just one way of splitting the matrix, right, just a special case, right, of splitting, right. We will be able to come out with different way of splitting, right, the matrices, right, as long as, right, it satisfy the outer products view, right, of matrix multiplication, right. We will be able to use it, right, as long as we manage to break down, right, the matrices into a smaller matrices that can allow us to key in, right, the entries of the matrix into our scientific calculator. To begin, right, we have to first switch our calculators into a matrix mode. Right, after that we key in the numerical values, right, for matrix A, B, and matrix C1, one by one. Right, so we start with defining, right, our matrix A. Right, we key in all the entries, right, based on, right, how we split D transpose, right, into two smaller matrices. Right, so after we key in the entries for matrix 1, we will be able to proceed to key in the entries for matrix B. Right, of course, we need to specify the size for each of these matrices. Then we will be able to proceed to fill in, right, all the entries and define our matrix B. Next, we will proceed to fill in, right, the entries for matrix C1. Right, after we fill in matrix A, B, and C1, right, we will be able to proceed to compute AC1 transpose. Right, which can be done, right, on scientific calculators, right, using the variable that we have defined, right, matrix A and matrix C in our scientific calculators. Right, this will give us, right, the numerical value from the first term. Right, and this will be stored in the intermediate solution, right, using a variable, right, known as, right, matrix answer, right, that actually store, right, the intermediate answers here. Right, so after that we can proceed, right, to compute the second term. Right, to do so, right, we will need to modify the matrix C in our scientific calculators into C2. Right, after that, right, we simply need to sum up the intermediate answers that we obtained from the previous step, right, plus matrix B times matrix C, right, then it will give us M bar, right, which represent D transpose Y bar. Right, so we obtain, right, our M bar here. Right, so after that we will proceed to compute N, right, which is defined to be the inverse of D transpose D plus lambda I. Right, so to compute D transpose D, we will be able to use the same ideas of the outer products view of matrix multiplication, right, with the A and B matrices that we have defined earlier. Right, so this is how we compute D transpose D. Right, with the A and B, right, the same A and B matrices that we have defined earlier. Right, the other tricks that we are using here, right, since it is difficult to implement this identity matrix in the scientific calculators, we will be able to use a trick here, right, because we know that the products between matrix A and matrix inverse, right, of A, right, is equivalent to I. Right, so with that, it will allow us to compute the matrix N. Okay, after that, we simply need to modify our matrix C again, right, with the M that we obtained earlier. Right, so we define our matrix C, right, to be M bar that we computed earlier. And to compute our W bar, right, it is simply the products between N and M bar. Right, N is available as the intermediate answers that we obtained earlier. Right, we simply need to post-multiply it with M bar, right, to obtain our W bar. Right, so this is the W bar that we obtain eventually. Thank you for watching.